This lesson is for FST on Lesson 3.9 about z-scores. A z-score enables a score to be compared to other scores in the same data set. That definition was taken off of page 206 in your book. The formula is very easy. The z-score is determined by taking your piece of data, subtracting it from the mean, x with a bar over it is the mean or the average, and the S on the bottom is the standard deviation. If you get a positive z-score, that tells you how many standard deviations that the score is, or the piece of data is, above the mean. A negative z-score will tell you how far below the mean the score is. So let's look at an example. Kim scored 82 on a math quiz. The mean score in her class was 64 and the standard deviation was 12. Find and interpret her z-score. So her piece of data, her score, is the x. We're going to take away from that the average, and then we're going to divide by the standard deviation. Keep in mind here when you are calculating, there are imaginary parentheses on the top of this fraction, so you'll want to subtract first and then divide. When you do that, you end up with a 1.5. So that means she scored 1.5 standard deviations above the mean. So she did very well on this quiz. Now we already knew that. We could tell that an 82 was well above the average, but now it gives you a more quantitative value to put to it to say that she scored 1.5 standard deviations above the mean. Another one is typical, more typical of what you're going to see for z-scores, where you have to compare two different grades. Jim scored 76 on an English test. That test had a mean of 70 and a standard deviation of 12. So let's record what's going on with that score. He got a 76, the mean was 70, and the standard deviation was 12. If you calculate there, you should get a z-score of 0.5. So he's scoring on average about half a standard deviation above the mean, which we already knew. He's 6 points above the mean, and that's half of the standard deviation. So we could have figured that out, but now we have a formal way of actually calculating that value. And then we've got the geography test. He scored a 66. That had a mean of 62, and the standard deviation there was 4. When you do the calculation there, obviously we're going to get a 1. So we know that he scored 1 standard deviation above the mean. So again, the numbers here are very simple. We wouldn't really need a calculation to figure that out. We could have just looked at the numbers and determined that. Most of the time when you're working with the actual formula, the numbers will be a little bit more difficult because you'll have decimals to work with. So clearly we can see that his z-score is larger for the geometry test. So compared to his peers, he scored better on the geography test than he did on the English test. So again, it's because the z-score is a larger number.